a way to tackle this. Of course, we're going to try to find out what decoupling actually is and what is not, what represents a solid idea, and how do they work together, and why it would work for you as well. Because there's also this skepticism which has to exist, right? Because you hear a new idea. The thing with programming is many times you hear new terms, and usually you don't have the experience with those specific terms, and you're like, yeah, well, I've done things in a specific way and they work. But there are also some, let's say, there's a lot of information that's behind a simple label that you use, and you can trust some of the best practices that are out there. Does this mean that things will never change? No, it doesn't mean that. It just means that when it comes to programming, even though there's a big component of it, which is art, in a way, the way you think about things, there are some patterns, some templates that if you follow, your code will be better. So this is kind of saying, well, if you're doing decoupling, your code will be better. This is where I'm going with it. So,
are you lying?
No. So this is what I was saying, dude. It's like the jargons are killing me. Like I hear all these words. What do they mean? I mean, you're saying decoupling. What actually are you referring to? And I say, no worries. That's why we're here, to discuss about decoupling and why it's a solid idea. So what is decoupling and what is not? Well, decoupling is not really decoupling. That's how I want to start. Decoupling actually means loose coupling. What's the difference? So, yes, many people do. So imagine this. The situation is like this. It's not that you're not creating relations between software entities, is that you're doing it in a smart way, in a strategic way, so that when components talk to each other or when given components are bound to change, you're allowed to do so in an easy way. This is what loose coupling means. It means that when you're interacting with something, you're not interacting with that something in a very specific way, let's say. So what does specific means? Let me give you an example. So for instance, imagine you have Hansel and Gretel, it's a boy and a girl, and they're having a relationship. And, yeah, and Hansel, I think Hansel is the boy. But yeah. So Hansel goes to Gretel, and he knows that Gretel has a bag in which she keeps food, right? So for that reason, he goes into her bag and starts to eat food, right? But at one point, Gretel may decide that she doesn't want to keep food in that bag anymore. She wants to keep poison because she's a psychopath. So because there is no contract between the two of them, and because Hansel, at this point, the boy decides that it's a good idea to get food from her bag, as he usually does, because he knows there's this convention. He didn't establish this convention with the girl, but he knows he can take food from her bag. So he reaches into her bag, he gets the food, but it's poison instead. And he's like, why did I die? Why did the project fail? Well, it failed because Mr. Hansel, in this example, thought that it's good to make all sorts of assumptions and go into the internals of how Gretel works in this case and do things in a very coupled way, because he wants to know what's exactly in the bag, and he doesn't need to know. If, for instance, in the same scenario, you have Hansel going to Gretel and telling Gretel, hey, Gretel, I want food. That way, there's a contract between the two of them. And when he goes to Gretel, if Gretel changes the way she handles food, so for instance, she doesn't put the food in her bag anymore. She puts the food inside her backpack. Then it's very easy because the contract between the two of them is goes something along the lines. Hey, I want some food, and it is the responsibility of Gretel, the girl, to deliver food as the contract says. So you see, the thing is, the coupling between the two of them doesn't exactly disappear, but it's more loose in the sense that me as the boy doesn't know what the girl does, which is true, by the way, in case you're not married, but that's that's a different story. So, right. So decoupling is not decoupling. Decoupling is this idea that when you have modules, you make them in such a way that they operate between each other in an abstract way. What's interesting about it is the fact that this concept does not apply only to a specific level. Like the first intention, well, the first impression you would have is, well, if I want to apply decoupling, which means this kind of relationship, I'm going to apply it only at my API level. Because at the API level, then you think that you're going to have things sorted, right? But it's actually true at even smaller levels. So, like if you have a car, it's still a good idea that within the car, within this car system, you don't know exactly how the engine works. What you need to know is how to start a car, that's exactly how the contract should be: start and accelerate and brake. And as long as this contract is respected, you don't care how the things actually work at a very low, deep inside. You don't need to know that it's uh, gasoline or what's the other, diesel. Yeah, but you do need to know if it's diesel or gasoline if you're fueling the car, right? Yeah, because otherwise you mess up your car, essentially. So you may have noticed, if you have a keen eye, that I did not say that decoupling is a solid idea. I said decoupling is a uppercase solid idea. So you say, well, what's the difference? The difference is because HINT, it's an acronym for something. So what's an acronym? It's when you take multiple letters, beginning letters of something, and you say, well, this is anything. That's the differences. So the thing with solid is that Americans really, really like acronyms. So they come up with this thing and they get some central ideas about how you should write code and say, well, I guess we have solid, and I'm gonna tell you this as a homework. If you want, you can go home and you can search about it. But there's also stupid, which is like solid, but the other way around. It's like matter and antimatter. There's solid and stupid code. And S stands for the stupid part. It stands for singleton, just so nobody thinks that I'm just making this up. So
it's not from smart.
What?
Not from smart.
Yeah, I know.
Stupid.
Stupid is just like how you can write bad code. It's like a best practice, but for writing bad code. So what is solid? Solid comes from, it's actually more than an acronym, because it's actually an acronym of acronyms. In the sense that S stands for single responsibility principle, O stands for open closed principle, L stands for list curve inversion principle, I stands for interface segregation principle, but they will all end with SP, right? ISP, so on. And D stands for the dependency injection. Yeah. Well, here's the thing. We're gonna get to that, but inversion of control dependency injection, we'll see it a little later. So what does singular responsibility means? When you write your code, you want that a piece of code, no matter how you look at it, you want it to have a single responsibility. So if you have a class, you don't want that class to do multiple things. This is a good idea usually, because if you keep the code structured this way, then you make sure that you're not polluted. But you're gonna say, right? You're This is logic, and you think, well, I'm just creating a console app. Then it's fine, right? Put the code whatever you want, but realize that you will need to refactor. Victor was giving an example. He's modifying the 1,000 classes because refactoring, here's another hint, is a normal process as a developer. Of course, when you're starting out as a developer, you're thinking, oh, if I change things, I break things. But there are ways on how you can prevent that, right? So what I'm trying to say is that at the beginning, it may be the case that it's not necessary for something to be a separate class, but as your project evolves, then that need may become real. So what I'm trying to say again is that your code should not be treated as a dead body, right? You're not that doctor that does autopsies. You're that surgeon who performs heart surgery. You want to keep the code alive. So from that perspective, you have to go to your code and treat it as it is alive, which means you have to change it according to the needs that you find out while you're changing it. Nobody expects that when you go to, especially when you go to a new domain, and the domain is usually like a set of business rules that somebody, for instance, if someone would come to me and would say, I see Jack Daniels in front of me, so I'm going to use that as an example. I want you to build something for Jack Daniels. I don't know that much about whiskey. I know it's made out of barley and crops and stuff. Yeah.
I'm having nightmares.
Okay. Well, Glenfiddich probably is better for when you start out. But what I'm trying to say is that you don't know a lot about domain, so you may make mistakes. But when you realize that in your given domain, in this case whiskey, a certain concept is separate, you have the duty as a programmer who writes good code to take that concept in a separate software entity, right? This is the S, single responsibility, which means, well, I did a bit of a mistake there in the sense that you want to keep the responsibilities separate. You do want to group things that are similar in a similar thing, a similar software entity, right? So that's one. We have 4 more to go. O means open closed. Now this one, people are like, you're fucking mad. And why? Because this one means that you want to keep your code open for changes, but closed to modifications. And people are like, this is worse than the Catholic Church. And why? The reason why it's so difficult is because it's really hard to understand that you can actually create something that is called, well, but it has to do with the last one, right? Dependency inversion or dependency injection or inversion of control, because what essentially what you're trying to achieve here is to create your code in such a way that you don't have to change it. But you're gonna say, well, how is then open for changes? Well, it's open for changes because remember Hansel and Gretel, they have a contract. So if another person instead of Gretel comes in, let's say Anna, and Anna has the same contract for providing food, Hansel doesn't care. The boy is just like, I want food, woman. And the woman knows that interface, so she can provide food. So did you notice the difference? Here is not the same person. We're not talking about the relationship between the same person. We're talking about the relationship between 2 different persons. Did something change from the perspective of Hansel? Well, unless he's blind, but like I'm trying to say is that when he asks for food, he still gets food. So that's the important idea. So you have contracts, which it's a fancy word for usually when I'm talking about contract, usually that translates into interfaces, but a more appropriate definition would be abstractions of any sort. Because in the example that Victor was giving earlier, you notice that he was mingling with an abstract class. That's an abstraction as well, which was not needed in that case, but nevertheless, it's an abstraction. So again, the idea between open closed is that you want to write your code in such a way that you understand really well what the business domain is, and everything else that's not business domain is used as an interface, as a sort of abstraction. That way, you know pretty sure that you have covered the domain, which is the business logic. So, for instance, if I'm handling whiskey, as I gave in the other example, I know pretty sure that when it comes to whiskey, I know exactly how that business is going to go. So, from that perspective, I don't need when I have it goes down even to the class level. So even at class level, you can achieve this because you can make a class so it consumes abstraction, so it doesn't need to change when requirements change. And I'm going to give you a very simple example. Usually this happens with the infrastructure pieces, and infrastructure means something like, for instance, you have a database that it's saving the data, right? Database. But what has been noticed recently is that some people now prefer cloud. Now, what do you do? Because if your code is in your web pages, for instance, you're pretty much screwed. Maybe you don't have the resources to refactor your entire application in one go to replace the database from that old thing that you're using because it was, I don't know, 1999. And then it was a very good idea to use this ActiveX component. And so, but if you have an abstraction, you don't care because you just swap, you just make this abstraction, implement this, you just make this infrastructure component, implement this abstraction, and suddenly everything works. So this is, in a way, if you know design patterns, it's kind of like the adapted pattern, but you have the domain component who's saying, this is how you have to adapt, people. This is how I work. And what this creates is that for the other people can plug in into that behavior and the component will work. So L stands from Laiskov, and everybody's like, whoa, what's that? It's a woman, I think. So it's more of a, the principle is this, that if you are using something, you shouldn't know its inheritance in order to use it. And you can see this. Why is that? You don't want to assume that a specific component that comes in has a particular behavior. So for instance, you would say, well, let's if you look on the internet, the classical example is with square, circle, and things, and you say, well, if it's a square, return me that it has four sides. But you're deciding, isn't this similar with what I was giving an example with Hansel and Gretel? That Hansel is saying, well, I know the food is there. So it's very similar in that way, because you as a consumer of that class, you're saying, I know how you're gonna behave. This is not how you should write code. You should tell the code to execute, not put questions. So are you telling me you're actually a square? Well, then that means no. It's more like, hey, square, what's your surface? That's it. If you're dealing with surfaces, of course. But this is where it comes that you have to know your domain and you have to know what kind of problems you're trying to solve. So I'm going to move on to the next one, which is a very simple one, and it's again tied to this decoupling thing. It's interface segregation, and even though it sounds fancy, it's not. It actually means that if you have a large interface, it's probably more than one interface. And you say, well, it's one interface. Yeah, I know, but it's probably more than one interface. in the sense that probably you should look at that interface and try to extract what it actually represents, because it could actually represent multiple perspectives. And then you're going to say, yeah, but I mean, I have one big interface and everybody inherits that and I'm happy. Yes, you are happy. The ones that implement the interface are not happy. I say, can you give me an example? Yeah, sure. So imagine this. Imagine you have an interface that saves the data and sends emails. Now you're gonna say, okay, I can understand that. Where's the problem? So someone says, I want a new email client, right? And in your application, you're actually using this interface. So suddenly the new email client inherits this interface because he wants to use your system, right? Or you want to use that new email client. And suddenly you realize, what the heck is save? I don't have save for emails. What's this? Is it a draft? Should I save a draft? Is this what it means? It has insert. What's insert for an email? It has delete. Okay, I can figure out what a delete, but it also has delete email. What's the difference between delete and delete email? You're creating confusion. And the reason is because these are you're creating an artificial coupling between two concepts that have nothing to do with each other. One of them is a storage, and being a storage, you should, well, have storage related operations, or another word for that would be repository. So it's a repository, has a repository, and the other is a sort of email service, and it has email service related operations. I'm giving dumb examples so you can kind of figure out. Usually, in reality, when you're handling real code, the differences may be much more subtle. But this is the kind of thinking that you have to deploy in order to realize, what am I doing here? Usually, it won't be you who is filling unless you're also implementing the email service, because then it will be like, God damn it, who wrote this interface? Oh, it's me. God damn it. So remember, keep your interfaces as small as possible. In a way, this way, it avoids confusion for everybody. And imagine someone who's also using this abstraction. Let's not talk about the implementer side. Let's imagine that I'm just a guy who wants to use this interface because I think it's very cool. Look at this email and storage interface. I want this. I use this abstraction. I know dependency injection will do the stuff for me. And then I'm like, I'm going to send an email. And I'm going to say, well, my email and storage service dot. And then it's like, damn it. I just want to send an email. Is this the right interface? Because these are too many damn methods. That's because you've created an artificial coupling between two components that make no sense together. And it can happen. It seems ridiculous. It seems like it could not happen, but it usually happens. And it happens even in frameworks from time to time. So it's not like, don't feel bad, is what I'm trying to say. But what you should feel, you should feel there's some, how should I call it? Ugh. When you see something like that, you should be like, oh, no, this is not okay, right? Especially if it's your code. Because otherwise you can just curse on somebody and be like, goddamn developers these days. So what's the connection? Whoa. I forgot about the D. The D stands for dependency inversions or inversion of control. And this one is big. This is like, if when you go to a website and you have the keywords which are different sizes depending on how something was searched and how important it is, yeah, the D would be big. You're gonna get the D for that. But the point is that inversion of control is like the one thing that you have to really understand. It won't do if you just understand the definition. You have to feel the definition and understand how it applies to code. Because what dependency inversion says, well, the definition says something like lower modules should depend on higher modules, not higher modules on lower modules. And you're like, well, I get that. It's very it's very fancy. Now I'm gonna go have a coffee. No, like you have to understand that what it actually means is that normally you don't want to directly do anything. Imagine you're like you're this kind of uh, fancy. I was about to say businessman, but I'm not actually. uh, It's like the slave owners from America. Okay, it's not a pretty picture, but it's like you weren't doing what? Overseer, something like that. So it's like you will say, well, I need this data saved. I don't care where you save it. I need I need a new email fetched. I don't care where you get the email from. I need this well, what's the new message that has come through the pipeline? I don't care where you get it from. And if you think like that, you will start to realize that many things in your application become complicated for the domain that you're trying to achieve because you're intermingling infrastructure components with your code. And if you extract them, your domain model becomes more clear, and the business that you're trying to model becomes obvious because you realize, well, there's, but then, of course, you're going to ask, but where do the messages do come from, right? And
They are hidden variables.
are they hidden? Are they hidden variables? Who saves my data? You know, man, 'cause I'm just saying save, and this is just an abstraction. It doesn't really exist. Here's the thing: it does exist, right? Because you know about that Mongo storage or SQL storage. You know it's there. But then comes the second part of the information about dependency inversion, that there is a piece of software which is like the architect behind all of this. You know that part of the application which says, well, if you're asking for storage, you're gonna save there. If he's asking for messages, you're gonna connect to the socket and fetch it from there. There's this there's this architect. This is called the application layer normally from the architecture point of view, but it essentially means that it's the place where you decide how the application fits together so it works. Right? So it's not just abstraction because the code plot twist. Well, it's not plot twist because it's obvious, but it won't work if your all of your abstractions don't have a concrete implementation. So you're working with abstractions, but you need concrete implementations. So, right. So right now you have a pretty complete idea what you are trying to do. Even though some of you may be just like, what was with the Hansel and Gretel thing? But the point is, decoupling is in a way solid. So if you write your code in a solid way, in how I've tried to describe again. I'm not expecting that everyone goes enlightened from here. But the idea is that if you write your code according to this, and by the way, solid is the best practice, which is something that is like what you do when you want to do the best, right? So, for instance, for athletes, they when they train, they go to the mountains, so they have less oxygen. So when they come back to the running track, they have a boost because they were training without oxygen, and now their body has a lot of oxygen. So now they can sprint. So this is kind of the same. In a way, you can think it of the same way. If you write your code in a solid way, that makes sure that your application, when it goes into the real world, has a bit of a boost. It you can change it easier, you can maintain it easier, and you can understand the problems that your application is trying to solve easier. Because remember the topic of this evening, the point is to make it so that your application is simple. And in order to make it simple, sometimes you have to do things a certain way, which is like a tested way, let's say. And some of you may still be like, okay, but why is this a good idea? I still don't get it. Listen, have you ever heard of the scientific method? Like the scientific method says this: you propose something, right? If it's bullshit, forget about it. If it's not bullshit, then try to prove it that it works. Now, the thing with solid and the thing with decoupling is that it has been proven that it's efficient when you write code. So it's not something that me or Victor have invented. This is something tested in the software community, and it has been proven to be efficient. And if you manage to achieve this mystical decoupling, you're like, I'm all set. I have the courage to do this, to sell my code to Google. I don't know, or maybe the aliens that will visit us really soon. You say what aliens are going to visit us? Don't overthink it. The idea is that your code will be valid at the galactic level, beyond Earth, right? So, and some of you may still be skeptics and be like, I don't trust the scientific methods. Well, then you should throw your phone away because it works because of the scientific method, and the light in this room and many other things work because of the scientific method. So unless you're living a lie, well, then you should start to reconsider some of the things. Okay, I won't go into details. But some of you say, well, okay, I trust you. But you see, my project is special. It's like this special kid, who cannot. I tried. He doesn't speak. Now, remember this. It won't work if you are the revolutionary Rome must fall and it has to happen in one day kind of guy. What do I mean by that? So if your mindset is, I'm going to go to my workplace, I'm going to go to the project that I'm working on, and I'm going to change it. It's going to be solid. Tomorrow, I wake up, it's going to be solid. And you drink a few beers before, the code is the same. It won't happen that way. Reality doesn't happen that way. And it's actually counterproductive to do it that way. Because you have a lot of ideas, but if you're not really capable in what you're trying to pull off, it may cause the entire project to fail. Because remember, the project is still working somewhat. The project is still getting you money somewhat. But the idea is that you want to innovate. You want to create this beautiful thing. And in order to create beautiful things, it requires some effort from your part. You have to understand the concept. You have to understand why the code, why the last release it was a failure. What was the thing? Oh, it was because I changed one thing and another thing broke. So maybe it's a thing of coupling between the components, and maybe I could create such a scenario in which I test a smaller component, and that way I realize that this is working properly. And the thing with, I mentioned that dependency inversion is like kind of the most important one. It's important from another reason as well, because if you master dependency injection when it comes to your project, you open a new chapter, which is called, some people, how like you have Catholics and then you have Lutherans and all sorts of things. It's the same. There's a cult which is called TDD, right? And they're like, you have to write your test first, man. That's the only way to salvation. And the thing is, yeah, but like most people are not used to it. So I say the first step would be kind of make your project to be injectable, so that these dependencies are injectable, and then your mind will. There's a picture on the internet, and I was talking with Dan before this, in which there's a guy and his mind keeps expanding. And the thing is, once you realize how useful dependency injection is, your mind expands, and you're like, okay, but that means I don't really have to save the data in the DB when I create the test, because I could use an abstraction. right? This means I will run my test instantly, right? And so the world of unit test has this important purpose. And the important purpose is this. If you manage to do it properly, if you have a module, you can 100% unit test it. So if someone goes inside and does some bullshit, tests will start to fall. It will be like the apocalypse if someone messes up. And unless you have this weird work procedure in which everybody goes in the code and starts to change it randomly, your code will be solid. Because if someone changes something, you will know exactly how and why that change breaks your code. I won't get there's a whole topic on what makes a good unit test, because you can write bullshit unit tests with bullshit names that when the test fails, you have to go and debug to see why it fails. And because the name is so strange, you still don't know why it fails. But the point is, you have to take it systematically in order to reach this state of decoupling and solid code. It will be like when you say solid, you usually think of a rock. Imagine is that you're not just creating a statue, you're taking a chisel and you're starting to create a statue. And the code initially will be just a rock, but you're trying to create from it a nice work of art. And in order to achieve that, you have to start chiseling, because if you don't chisel, well, you'll be the guy who goes at the marketplace with his rock and say, "Oh, just a rock. It's a special rock. Yeah, buy my rock." And the other guy's rock will be like breakdancing or something. So I still have questions. I'm listening. Do you have questions? This is a weird way of saying I have questions, but Q&A.
Yeah, you mentioned TDD. Have you actually tried it?
Yes, and I know it works, and I know it shapes algorithms, because that's kind of like one of the things that it tries to achieve. But I'm saying that for someone who has less experience with,
It will be hard.
it will be hard. It's like saying, well, take this backpack and jump off the plane. But I never done skydiving. You're gonna be fine. Just follow the instruction, and then the guy jumps with the backpack. He's like, oh, look, there's a manual, and it has 100 pages.
Yeah. But parachuting always works in movies.
So unless you picked that girl's backpack, which was in the plane, and it was not a parachute.
So you think PDD is not for everyone, right?
What?
So you think PDD is not for everyone?
Well, I would say that there. I do. Okay, so
You have to
There are-
understand where from TDD come.
Sorry?
You have to understand where TDD comes from.
I understand where PDD comes
Yeah,
from.
you
So
understand.
I'm just asking
It comes
people.
from these dynamic languages which are working with dynamic types like JavaScript, PHP, Python.
I wouldn't go that.
stop. No, don't go there.
From the guys that
For
don't
the
have
name
a
of
real
this-
compiler, they have just the test instead of the compiler. And they do a lot of manual work just to
Also,
do the
you're
work that
against
the
TDD.
compiler does. Yes,
So you're against PDD?
yes, I'm against TDD.
I saw an
A lot
article.
of unnecessary work.
Yes.
You can think that the tests are somehow like
Yeah,
a fail-safe, like or
Syntax checker.
not syntax checker, but
No, they kind of create this.
it's like a
fail-safe.
redundancy system to your code.
Yeah.
So I in some ways I agree with you that people are misusing unit tests and probably
No, it's more than misusing.
they probably write shitty code using PDD, but they would write the same shitty code without using TDD.
Yeah, but the problem with TDD is that if you write the code in a TDD way, what happens is that you have your shitty code, which is as usual, and you have the TDD shitty code. So you have two shitty codes. That's the main issue with TDD in a way. So in case a bit of context here. So what TDD states is that you would have to write your test first and make sure that the test is failing because you don't have the code there, right? So you write a test, you see that it's failing because the behavior is not there. Then you implement the behavior, right? But there's a third part to TDD which is a bit harder, which is the continuous refactoring, which people lose it. Like they're like, I don't know what I did here, but the test was ran, and suddenly I'm writing code for NASA. I don't know, rocket science. I'm not saying that TDD is bad. I think that it has its place, but I'm also saying that I read an article which was an interesting proposal, and it was like, don't write tests, write some, and most of them integration. So the idea was behind. It seems strange, but the idea is that what it was trying to say is that if you have, the 80-20 rule, something like that. If you have some integration test that make sure that your whole test is running. From the product perspective, I think this is better, right? The integration test, because it makes sure that their core business is not at risk. But there's a whole debate, because if you do write your unit tests properly and you're writing them, for instance, from a domain-driven perspective, your unit tests actually represent the business, and it actually represents the test cases that the client is expecting. So I'm saying that if people would understand and use it properly, you would not need QA. Sorry, QA guys. Because the thing is, like, you would have test cases, and you say, if this is happening, this is the result. If this is happening, this is the result. This is happening, and you have everything covered. Because you know that you know the domain well enough, but this is in conjunction with domain-driven design, which is a different topic. So that's why I'm saying, well, in reality, you know what happens if you apply domain-driven design and you don't know domain-driven design. It's a pile of shit.
But TDD is very simple. It just says, write your unit test first.
Well, yeah, but I'm saying if you write bad unit tests, it doesn't do anything. Yeah, and if your abstractions are not correct, it doesn't help you, because then again, you have to be very good at most of the programming concepts in order to write TDD, and that's kind of the issue with TDD, because it's not real. It's like the tooth fairy. I'm not saying that perhaps in 100 years. So I was hearing this interesting concept. Do you know, anyone knows Dawkins? So he's a biologist, right? And he said that our brain is
Richard Dawkins.
yes.
That pure revolution is something.
No. So he was saying that our brain is very flexible, and he was saying right now we're not comfortable with quantum concepts. Our brain is working at this mid-level kind of thing. Things not really big, things not really small. So when someone says, well, it's all probabilities, things don't really exist, your brain goes, wait, what are you trying to say? So he was saying that perhaps in the future, if in our education we would describe these concepts better, our brain could adapt and would understand concepts that now are very difficult for us. So I would say the same for TDD, in the sense that perhaps since many the strength of TDD cannot be denied, in the sense that once you have done it properly, you run the test, you know your application is well.
Yeah.
So-
and also it makes you like know beforehand how you will use your computer that you're creating.
And saying, by the way, Bozo, saying that, well, it's redundant. Yeah, that's what testing is, because your code should already work properly on those scenarios. That's the point. Somebody is doing something redundant in a way to make sure that your code doesn't mess up in production, where this guy sends $1 million and the other one receives 10 cents. There are $10 million on the wire. What just happened?
You should test that code.
Yeah. Other questions?
Yeah, you mentioned dependency injection, and have you ever seen a case where dependency injection was misused? Or more often misused than used correctly?
The example of what Victor was giving, it's kind of a hint on how it can be misused, but I think it can.
Yeah, I have a debate.
So the thing is, you have to keep. I talked about solid. There's another principle which is called KISS. You know what the KISS is, but it's also an acronym, and it stands for Keep It Simple.
So you came late.
I did.
You already had kisses.
You slept late.
Keep it simple and stupid.
No, it's keep it simple, stupid. Keep it simple, silly, with comma or without comma. It's
Yeah.
all kind of.
So the idea is that you don't want to complicate. So when it complicates things, it's misused. Other questions?
I was reading the other day something in the lines that if you correctly implement the principle open close, then the risk of substitution principle, basically dependency inversion becomes with them.
Yeah.
What's your
So many people, when they're learning, the question is the following. You read an article which was saying that if you apply open-close principle together with list inversion, substitution, then dependency injection follows. I would say it's the other way around, in the sense that if you properly apply dependency inversion, then the other kind of follow. And this is one thing, when you're learning principles in programming, they are not made so they're exclusive. It's not like, I'm just going to apply open close. No, I don't want to do it. I don't want to do dependency inversion. I'm just doing open close. There's no such thing. You're going to do a lot of principles that are interconnected. It's more like a web. What?
They are coupled.
They're coupled.
Principles are coupled.
Yeah, principles are coupled. And imagine this is a simple way how you can remember something. That's why they use this acronym SOLID. But in reality, the concepts behind them. That's why I said in a way decoupling is solid, because like you're trying to achieve something, and that's something that you're trying to achieve. It's a group, so they're working towards the same goal. They might have differences, but they're working towards the same goal. Awkward silence moment. Check.
Kiss.
Kiss.
No,
Any other questions? If not, thank you. Probably I'll be around for some time. So if you want to ask something after I finish this, please feel free to do so. And thank you for your attention. And hope you've made your first step towards programming enlightenment.
Unde e codul? Asta e întrebarea.
Too much code. Let me just sign up. Huh?
That is the question. Where is the code?
Where is the code?